The moment everything changed at exactly 6:42 a.m., long before most of the world had finished its first cup of coffee, a single hydraulic pulse echoed across Tesla's factory floor. It wasn't loud in the traditional sense, no explosion, no alarms, but it carried weight. Literal weight. Thousands of tons of pressure surged through steel columns thicker than tree trunks, compressing molten aluminum into a single, flawless automotive structure. This was not the Giga Press the world thought it knew. This was bigger, stronger, smarter, and according to engineers inside the factory, this upgrade may quietly redefine how cars are built, not just at Tesla, but everywhere. For years, Tesla's Giga Press was already considered revolutionary. It replaced hundreds of stamped metal parts, dozens of robots, and miles of welding lines with one colossal machine capable of forming entire vehicle sections in a single shot. Competitors called it reckless. Traditional automakers said it was impossible to scale. They were wrong. Now Tesla has upgraded the Giga Press again in size, force, precision, and intelligence. And this time, the implications go far beyond manufacturing speed. This upgrade strikes at the very economics of car production itself. This is the story of how Tesla made its biggest machine even bigger and why that could make cars cheaper, stronger, and faster to build than ever before. Chapter 1. Why the original Giga Press was never easy. To understand why Tesla upgraded the Giga Press, you first need to understand what it was fighting against. For over a century, car manufacturing followed the same basic playbook: sheet metal stamping, hundreds of individual components, welding robots, sub-assemblies stacked onto sub-assemblies, entire factories built around complexity. A typical car body could consist of over 300 individual metal parts, each one stamped separately, each one handled by robots or humans, each one introducing tolerances, misalignments, and delays. Tesla looked at this and saw inefficiency. Elon Musk famously described traditional manufacturing lines as alien dreadnoughts, massive, slow, and overly complicated. The Giga Press was Tesla's counterattack. Instead of assembling hundreds of parts, Tesla cast large sections of the car body as a single piece: front underbody, rear underbody, eventually entire structures. The benefits were immediate: fewer parts, less welding, faster assembly, lower cost, improved structural rigidity. But success created a new problem. As Tesla scaled production, the limits of the original Giga Press became clear. Vehicle designs were evolving, battery packs were becoming structural, new platforms demanded even larger, more integrated castings. The old press was revolutionary, but it was designed for yesterday's cars. Tesla needed something more. Chapter 2. The upgrade. Bigger than big. The upgraded Giga Press isn't just an incremental improvement, it's a leap. Sources inside Tesla describe the new press as exceeding 9,000 tons of clamping force, with internal discussions pushing toward even higher thresholds for future iterations. That's enough pressure to shape massive aluminum structures with extreme precision in milliseconds. But size alone isn't the real story. The upgraded press features larger casting envelopes, advanced multi-zone thermal control, faster injection cycles, AI-assisted quality monitoring, integrated post-casting cooling optimization. In simple terms, Tesla didn't just make the press stronger, they made it smarter. Where earlier presses focused on brute force, this upgrade emphasizes control. Molten aluminum flow is now monitored in real time. Micro-variations in temperature are corrected instantly. Internal stresses are minimized before the part even cools. The result: bigger castings with fewer defects and tighter tolerances than ever before. This allows Tesla to cast sections that were previously impossible. Structures that integrate mounting points, crash structures, and battery interfaces into a single unified piece. One shot, one part, one perfect alignment. The structural battery, CIO and an ECITO, and the real reason Tesla needed a bigger Giga Press becomes obvious when you look at the structural battery pack. Traditional EVs treat the battery as cargo. Tesla treats it as architecture by integrating the battery pack directly into the vehicle structure. Tesla eliminates redundant frames, lowers weight, and increases stiffness, but this approach demands absolute precision from the surrounding castings. The upgraded Giga Press makes this possible at scale. Front and rear mega castings now align directly with the structural battery pack, forming a rigid, load-bearing sandwich. This reduces the number of body components dramatically. In some configurations, Tesla has reduced the body and white part count by over 70%. Fewer parts mean fewer robots, shorter production lines, smaller factories, faster ramp-up times. This is why Tesla factories look different from traditional plants. They're shorter, more compact, more modular. The upgraded Giga Press accelerates this trend. Chapter 4. Speed. The silent WAPON time is the most expensive resource in manufacturing. Every second shaved off a production cycle compounds across hundreds of thousands or millions of vehicles. The upgraded Giga Press cuts cycle times significantly. Faster injection, faster cooling, faster ejection. While exact numbers remain confidential, internal estimates suggest throughput improvements of 15 to 20% per press. That means one machine can do the work of several older lines, and here's the real shocker. Tesla doesn't just build cars faster, they learn faster. Each casting generates data. The upgraded press feeds that data into Tesla's manufacturing app, which continuously refines parameters for future cycles. The factory itself becomes a learning system. Chapter 5: Cost. Where the real revolution, automotive industry runs on razor-thin margins. Saving $100 per car is considered